Hi and welcome. So in this video we are going to see about isolation centers question from May 2020 long challenge. Okay, so the question says, as a health expert, Vinay is keeping a close watch on the ongoing pandemic of coronavirus. He thought of a different situation where there are 26 types of viruses named Arona, Borona, Corona, Zorona and so on. That means from A to Z. You are given a string with length n. This is the string, this is my length. Okay, there are n people numbered 1 through n. For each valid I, the ith person is infected by exactly one type of virus named that S of I Orona. That means the first person is infected by this virus. The second person is distracted by this virus. Third person is infected by this virus. Okay, so this is nothing but the first character that we are having. The first person, the second person, the third person, the first character that we are having. Fine. You should answer Q queries. Fine. You are given C denoting the number of available isolation centers. So for each query we are given a C, that is the number of available isolation centers. Okay. Each isolation center has an infinite capacity, but with the restriction that two people infected with the same type of virus cannot stay in the same isolation center. Okay, there is also a pending queue. Fine, with infinite capacity, and there is no such restriction on the pending queue. Initially the isolation centers and the pending queue are empty. Each of the n people should be placed in either the pending queue or our isolation centers. Fine, we have to minimize the number of people that are in our pending queue. We have to minimize them. Now for example, when we see S, so this is infected by Sorona, and we have just one isolation center and a pending queue, one isolation center and a pending queue. Fine. So is there any person with Sorona virus inside the isolation center? No, so we can insert it. Fine. Is there any person with T? No, so we can insert it. Is there any person with A? No, so we can insert it. Okay, with A also. Then for Y also we can insert, for I also, for N also, for G also, similarly for H also, then O, then M, then E. Now when a person comes with again with a Sorona virus, okay, that is S, and we have just a single isolation center, we cannot put this person in another isolation center, so we have to move it into the priority, into the pending queue. Fine. So this now S will be moved to the pending queue. Fine. A is also already present in the isolation center, so A will also be moved to the pending queue. Fine. Then V is not, so we will be moved to this isolation center. Then E is already present before here, so E will be moved to the pending queue. Fine. So there are 3 persons in the pending queue right now. Then S is already present here, so S will be moved to the pending queue. So there are 4 persons. Correct. Now what about L? Now L is not present, so L will be in our isolation center. I will be in our pending queue. Why? Because I is already present in the isolation center, so therefore person is 5. Now F is in our isolation center now, and E is already in the isolation center, so therefore he will go into a pending queue. There are 6 persons that are needed to be going into the pending queue, and rest are all inside the isolation centers. So we need to find out how many persons will go into the pending queue. Okay, now in this case we just had a single isolation center. What if we have more than one isolation centers? Let's see the second query. So in this case it is given that there are 3 isolation centers. Fine. So for 3 isolation centers and 1 pending queue, what will be the answer? Just think about it. So this is one isolation center, this is another, and this is another. Fine. And this is my pending queue. Okay, this one. So now here we can simply write that S is here, T is here, A is here, Y is here, I, N, G, H, O, M, E. Now when S comes, S cannot be in this isolation center, but we should not put it into the pending queue because we have another isolation center, so S can be here, A can be here, V can be here or here, anywhere. E is here, so E cannot be here, but E can be here. Okay, S is here also, so we can put S in the third isolation center. Now what about L? L is nowhere, so L can be in any isolation center, I can be in any isolation center, F can be in any isolation center, E is here and E is here, so E has to be in the third isolation center. So there is no one in the pending queue, therefore for this particular case the answer comes out to be 0. So that is the question. So how to solve it? So it's a very basic implementation of the frequency array. Fine. So what we are going to do is, how many times a character is occurring. If we know that how many times a character is occurring, so see, s is occurring 3 times. Okay, so if we have 3 isolation centers, then each s will go to a different isolation center. But if we have just 2 isolation centers, then definitely one person will go into the pending queue. Correct? If we have just 1 isolation center, then definitely 2 persons will go into the pending queue. Correct? So whatever is the frequency of s and the number of isolation centers, that is ci, okay, if we subtract them, we will get how many persons of that is infected by coronavirus, that is s virus, SORNA, will go into the pending queue. Similarly, if we find out what is the frequency of t, fine, the frequency of t in this case is just 1. So if we have 1 or more than 1 isolation centers, then definitely no one from T virus will go to the pending queue. Similarly, for frequency of A, just find out what is the frequency of A. It is 2. So at least we need 2 isolation centers such that no one will go into the pending queue. But if we do not have, if we just have one single isolation center, so definitely frequency of A minus the number of isolation centers that we are having will give me how many persons will go into the pending queue. Fine. So what we need to do is, we just need to calculate how many times a character is occurring and then compare it with our number of isolation centers that is provided in each query. Fine. So how we create a frequency array for strings? So this is nothing but A, B, C, D and so on till Z. They are mapped to 0 to 25. They are mapped to 0 to 25. How? The ASCII values are subtracted. So A minus A, 97 minus 97 will give me 0, B minus A will give me 1, C minus A will give me 2, D minus A will give me 3 and so on. Fine. So this is 98 minus 97, 99 minus 97 and 100 minus 97 and so on. So what we are going to do is, in the frequency of the string that we are having, the character minus A plus plus in a loop. So this is how a frequency array will be created. If we have A, B, A, so A minus A will give me 0, so frequency of 0 plus plus, so frequency of 0 will become 1. Then A minus A is again 0, so frequency of 0 plus plus, so it will become 2. Now frequency of B will become 1 and here frequency of A will become 3. So when we have a when we go to the index 0, it says that it means that frequency of character A is 3. And how do we get the reverse mapping? That is from 0 to A is simple. We just add 97 to it and convert it into a character. Fine. So this is nothing but how do we create a frequency array. And once we have a frequency array, we will just check for a one single condition, that if my frequency of I character is less than the number of isolation centers you have, that means in our pending queue we will give frequency of I minus the number of isolation centers, and finally we will print this count. Fine. So let's see the code for this now. Here the condition is greater than, the condition is greater than. If the frequency of I is greater than the number of isolation centers, that means all the persons of this virus cannot fit into our isolation center. In that particular case, we will add the difference. Okay, it is greater than, not less than. So if this is this is the implementation, we get the T input, then N and Q as the input, then string as input, then we are creating a frequency array. Okay, so in a loop, just what I told you is simple frequency array creation. Now we get a loop for the queries. Each and every time take the input of M or C. Fine. For the 26 size array, just traverse it, and whenever for that frequency, if it is greater than M, whichever frequency is greater than M, in that particular case increment the count with that number of frequencies and then print the count. Fine. So this is the implementation for this particular question. Thank you.